Cool. Allegedly I'm live. Well, that's great. Let's see if I can pull up my dashboard here so I can actually see when people are chatting to me. Where's my videos? Nope. No. Okay. Most recent. Apparently that does not work. Wonderful. Go to my channel. Oh, yeah, well, okay, so it's listed there. Why can't I see it on here? FYI, using tablets is all round bad idea. Why can't I switch between? I don't want most recent. No, I suppose maybe I do want most recent. Oh, I'm a Muppet. There we go. No. Draft unlisted. No. All videos. No, it ain't showing up there. Okay, cool. Well, that's yep. Awesome. I'm a consummate professional, obviously. Right, I'll. Oh, good. There's 7 people watching. I'm such a tragedy. Give me a second to. I'm going to do it old school through Firefox on my old thing here. So, for reference, the game is called Silicon Zeros. It is a sort of a programming game, sort of a electronic engineering game. And it's probably better if I just show you how it works by showing you how it works. I know that sounds like a stupid thing to say, but youtube.com can't remember how to get to the live dashboard. So do a Big Rigs Let's Play. That's not really related to computer science. At least with this, I can use the excuse that it's tangentially related to the thing that I'm supposed to be teaching everyone. Sign in. Oh god, this is taking longer than expected. Type in my... Yep, that's that. And my password is... that. Remember, oh, 2-step verification. Ka-ching. Oh, I like the way it sent the message for the 2-step verification to the device I was trying to log into. Great security there, Google. Well done. Minecraft command blocks, not actually a bad idea. Maybe I will get that up and going. Right, okay, so I can actually see my stream here. This is not the best way of doing things, but what do I want to watch my own stream save for later? No, I just want the chat. Just show me the damn chat. Oh god, I can hear myself talking. No, that's all wrong. Pause. There we go. Where have they moved the chat to now? Does it exist? Is that a thing? Oh my god. Keep your boomer comments to yourself for now. Here we go. I was in mobile mode, not desktop mode. At least I've got 3 likes. It's like, oh man, yeah, tune in to watch this idiot. Like, he's supposed to be able to teach us computer science, but he can't even work YouTube. What a muppet. Right, I've got a chat. I've got a chat on the screen now. Brilliant. I can actually see what you guys are saying. Let's do the thing here. Pop out chat. That's what I wanted to do. Cool. Right, I can see your chat messages. I'm going to switch to the game. Hopefully, everything. Can you see? right, my face is going to be covering the different types of command blocks. I tried to move it. Actually, maybe I'll move it over there. Right, give me a second. Give me a second here. I'm going to move my face over here. That might be a better place for it. And then let's go back in here. So you should now be able to see I've got a palette. I've got control blocks. Hopefully you can see all of that. So I don't want Jack to... By the way, this is sort of... I've already gone through the tutorial stuff here. This is sort of like... so there's board one. You'll notice there's a cows thing. I kind of stole that when I gave you that that challenge, that programming challenge. Although it's the one that I gave you is fundamentally different to the one on here. So I've already been through all of this stuff, but we may come back to that. So the idea is that you are given these puzzles. I'm going to do the deref. You have a set of these different blocks that you can use. So there's this block which gives you a number. We've got this block which is an adder, and so you can see if I stick a 1 in there, and maybe I have another number here, and maybe that's a 9. When I add them both on there, 1 plus 9 is 10. Okay, super straightforward. I mean, I've never played Minecraft. But maybe that's kind of similar to how the command blocks things work. I don't know. That's something I'll investigate. All right. Don't at me. So it's going to get rid of. Gonna get rid of that stuff. Yeah, okay, not at all. Yeah, don't worry about it. It's fine. I've watched a video of Limmy set up some Minecraft command blocks that end up burning kids' parents. Maybe I'll do something like that. I don't know. But maybe you guys prefer an ASMR playthrough. Don't worry, I'm not doing that. Right, I am going to meet our investors soon. They make me somewhat nervous, and I would like to have something to show them. Can you replace each slot that contains the location of another slot with the value held in that other slot? Well, that's a mouthful. It will probably be helpful to mouse over memory for examples. Ah, I see. So you can see here, this is my memory over here. Slot 0 currently contains the value 10, right? What it needs to do, slot 0 needs to contain the value which is located at position 10. So that's effectively an address. We're saying this is the address of the data that we want to actually store in there. Okay, and then down here again we've got 3 at location 3. We've got a 1. So the that is actually an address. So the darker blue colours look like addresses, and the lighter blue colours are data. Look, I mean, this seemed like a good idea at the time, right? Readers produce nothing when reading from empty slots. In the spirit of scientific curiosity, I would recommend experimenting with Dash to see what modules do with it. Okay, thanks for that, Laszlo. So let's have a look at what we've got. We've got a read block, we've got a write block, we've got a latch block. Latches basically allows you to store temporary variables. And then we've got num blocks, and we've got an adder. So probably won't need all of these things. However, I want to be able to go through every single memory block. Okay, right. Here's how to do it. We need to read through. So it's 0 and it's 3 that we need to change. 0 and 3, 0 and 3. Okay, cool. So we need to read mem slot 0. What have I done? We want to read mem slot 0, and we want. No, we don't. And we want to find out And then we want to pipe that into another read block. And then that we want to write back to mem slot 0. Is this going to work? Boom, boom. I mean, this is going to be the least efficient way of doing it, I reckon. Also, I've just realised there's 100 different tests, and so we can't do it that way. We're going to have to go through every single slot. What a pain. Okay. I have to slightly rethink this. But I mean, you can see what's going on here, right? We're looking at memory slot 0. That value is 10. We're then saying, look at memory slot 10. That value is 30. We're then saying, write that into the original place there. Okay. Right, let's think about this. We need to be able to go through each slot in memory. But how can we possibly tell? How can we possibly tell if that is actually a slot in memory or not? Oh, because if you try and look at this, if I try and access a memory slot that doesn't exist, like -1, for instance, like it says when reading from empty memory slots. Okay. Okay. Right. So here's what we're going to do. We are going to delete that. I think this lot here is still bang on. But we need to start off. We're going to start off with 0. And we also... Right. So that is going to be added on there. We're going to add a 1 to that each time, and then that is going to feed back into that. Is that going to work? That's probably not going to work. Is that going to work? No, that will work to start off with. We don't need that. We can get rid of that. So, to start off with, we've got 0. We're looking at memory slot 0. Oh, we need to feed that into here. Right, so to start off with, we're looking at memory slot 0. We're reading that. We're then writing that back to memory slot 0, whatever that address is. If I advance it, here, let's go to the test thing. If I advance that 1 tick, rock and roll! We did it. Hopefully that made sense to everyone. Imagine if that's what my lessons were like. Me fumbling around for like 10 or 15 minutes and then saying, cool, we're done. You know what I'm going to do? I'm going to, in the spirit of proper teaching, I'm going to go back and explain exactly what's going on here, right? So I'll explain what each of these different components does, and I'll move them into a position so that it's easier to see what's going on, right? Let's consider these 3 units here, right? We've got a number which feeds into this adder. The adder always just adds together the org end and the add end. They're fancy ways of saying the first number and the second number, okay? So every time we cycle through, it is going to add 1 onto this number. In fact, to make it a bit clearer, I could probably do this. Instead of having that like that, and that like that, I will make that loop round to that one and that join on there. So you can see, to start off with, we have a latch. The latch currently has the number 0 stored in it. Okay. When we advance 1 tick, what's going to happen? That 0 is going to be fed round into here. This then adds 1 to that number, and then that answer gets stored in the latch. Okay, so then the stored value will be 1. The next time we tick round, that 1 will be fed round into here. 1 will be added to it, so we'll have 2. So this is basically a counter. Okay, every time we tick around, that is going to be adding up. In fact, I think I can just tick forward 1 tick. So you can see I tick forward, we've stored the number 1, and then we've prepared the stuff for the next tick, and so on and so forth. We tick forward again, we've stored the number 2, that 2 has been fed round. I don't know why I'm pointing at the screen because you guys can't see my finger. That's been fed round, we've added 1, and then we're storing 3 in there. We tick round again, and we get 3, and so on and so forth, right? Let's go back to the editing. Meanwhile, this happens. That 0, if I just pull this other block up here, this is the read-write block. Okay, so this 0 is feeding into the memory slot to be read and also the memory slot to be written to later on. We read from whatever value has been pushed into this read block. Okay, so the as I've explained, this is just a counter. That's going 0, 1, 2, 3, 4, 5, 6, 7, over and over until we reach the end of what we're doing, yeah? Which means that we're going to be going through memory slot 0, 1, 2, 3, 4, 5, 6. Now you'll notice in my list over here, there aren't slots 0, 1, 2, 3, 4, 5, 6. It goes 0, 1, 2, 3, 10. Well, what happens if you feed a memory block in there that doesn't exist? It pulls out this empty value. And if you feed the empty value into here, in fact, I can show you. If I step forward, you can see here we've read in the value of slot 1. The value is -1. We're then trying to access memory slot -1, but it doesn't exist, which means we are now feeding in this empty value. If you try and write an empty value to a memory slot, it will just leave whatever's already in there. Okay, so we're trying to write nothing, literally, to memory slot 1. That won't erase what's already in there. It just leaves it as it is. Okay, we advance one more time. We're now reading memory slot 2. In memory slot 2 is the value 20. That gets pulled in here. We're then feeding that into our second read, which reads memory slot 20. Well, memory slot 20 doesn't exist. So we're in that same situation where we're going to write nothing again there. We move forward again. This time, we've got memory slot 3. Which has the number 1 in there. We pull out the value 1 and we read what's at address 1. Well, at address 1 is -1. So this time we've actually got some data which we're going to write. And we're writing it to the same memory slot that we read that original thing from. Okay, so this is essentially indirect addressing, but with these weird discrete components. So when I run it forward, it just lists through the whole thing. I wonder, actually, if I go back to the puzzle, I wonder if I can test it with the different tests. Go back to edit. Can I test it with that? Let's try. Yes, I can. So you can see here, it performs exactly the same process, regardless of the bits that we fed it. Okay. Pretty neat. Sir does stream on Twitch, but not in an educational capacity. So there you go. We can't see you. Head is in the way. My head's in the way of what? Don't know what that means. Anyway, whatever. Oh, was my head in the way of the thing that I was pointing at? I don't know. Let me just double check. My head's not really in the way. Is my head in the way? I don't know. Your head is in the way of you. Head is in the way of head. Cool. Glad we got that sorted. Anyway, so on to the next puzzle. That was reasonably difficult. but you know, let's do it. So we go to the puzzle select. So that was our dereference. You'll notice that as we complete these different puzzles, it allows access to the next puzzle in there. So maybe let's have a look. I'm kind of avoiding Alternator because it's like complexity hard. That doesn't really fill me with confidence considering how long it took me to do that one. But anyway, let's see. Is this game free? I got it for free as part of the bundle for racial justice on itch.io. I think it's about 15 quid. It's not amazingly expensive. But check it out. It's called Silicon Zeros. I think it's on. You can get it on itch.io. You can get it on Steam. You might be able to get it on GOG.com as well. Don't know. All I know is that it was part of that bundle. I have no idea what the cost is. I think full price is about 15 quid. Let's have a look here. Right. Okay. This looks a little bit more complicated. I don't want Jack to hear us working on this. We're trying to build a machine that can execute instructions, okay? To execute instructions, you read them from memory and then do what they tell you to do. Obviously, right? You should decode and execute the 0mem instruction in each slot. You can mouse over instructions in memory for more info. Let's have a look. Set memory slot number 74 to the values. Oh, okay. So it looks like 0mem is the opcode here, and 74 is the destination. It looks like in later puzzles we'll probably get more complicated opcodes with these source and target values. But let's see. Let's see what we can see. So I apparently have... Ooh, I've got a new module, the control module. How does that work? This is the first time. So instruction. Ah, okay. So this is the decoder. This is kind of like the... I guess kind of like the control unit in an actual CPU. So we will set up our counter as we had it before, so we can continually add 1 to our value that we're going to use. And then, boom. Okay. Okay, right, I'm going to have to read that from memory. That ain't going to work. So let's move that out of the way. Let's get a reader. We want to read the value at that memory slot. There we go. It's pulled it out. Is this just like the fetch, decode, execute cycle, right? We're feeding that into the control unit. Boom. Which means now all we need is a write module. And that is the memory slot that we're sticking in there, and 0mem is set memory slot to the value 0. Well, that's easy enough. We just add that in there, and let's change that value to 0. And then we should be done. I don't recommend getting games on Pirate Bay. If a game's worth playing, it's worth paying for. And 11 quid, if it's on Steam for 11 quid, that's not stretching it, really. That's not breaking the bank. I'm sure you could, if you don't have any source of income, I'm sure you can badger your parents and into letting you do some extra chores, or you can go knocking on doors and see if people need their cars cleaned or something like that. Don't pirate games. Here we go. Let's test it out. It works. It works. It works. It works. We're done. There we go. There are some similar games with a similar concept which are completely free. They're not always as good. There was one I had on Android. Oh god, what was it called? I might even still have it on my phone. I'm having a look for it now. Oh no, I can't find it. But it involved connecting logic gates together. The most expensive thing I've got on Steam is the Witcher Enhanced Edition for £1.49. Okay. My dad will never pay me for anything. Okay, I mean, it's time to get a job. A paper round, are they still things? I don't know. What I'll do though is I'll keep my eye out for similar games that are affordable. There's a couple of other games, one called Shenzhen IO and one called TIS 100. They're both made by Zachtronics, and they're less about putting the hardware together. They're more, well, Shenzhen IO is all about hardware, but they focus on low-level programming. So it's like using assembly language to make the puzzles work. They're really, really good games. In fact, I'm looking at getting a few copies of them so that we can have them installed on the computers at school, because I think they'd be a very good educational tool. So we'll see how that goes. Right. Yeah, so I'll keep my eyes out for similar games, or if I find a game, or maybe I'll do a giveaway, an amazing video game giveaway. Okay. There we go. So let's go to our puzzle select. So we're done instructions now. Set memory seems easy, so I'm going to leave that for now. Let's try the zeros. Okay, buddy, here's the plan. I just realised, actually, I don't know if I ended up actually posting this in the Discord. I shall check it out. Copy video URL. Post that in there. There we go. And let's get back to it. Right, where are we at? Unable to chat. Unable to connect to chat. Interesting. I didn't post it in the Discord. Okay, well, let's do that. Oh, I see you posted it in the chat though, AJ. Nice one. Thank you very much. I paste it for my sixth formers as well. See if they're interested in that. Who knows? They might be. They might not be. They might be more interested in other things. I can see I've got a wonderful 3 people watching, but that's fine. That's fine. Right, let's get back to it. Okay, buddy. Here's the plan. This company is going public in 2 months. Before that, we need something we can sell. Oh, by the way, this is supposed to be set like in the 60s or 70s. So the idea is that this is sort of like they're pioneering the work of actually building computers from components. That's sort of the background here. Your pals want to build all kinds of fancy trash computers. There's a market for what, maybe 100 of those? That, by the way, is a reference to something the head of IBM once said. How wrong he was. Little gadgets like a widget that replaces all ones in memories with zeros. Okay, cool. Is that what we need to do? Replace all ones in memory with zeros. So okay, I've got an even a newer thing. Takes 2 inputs and outputs the selected one. Okay. Input selector 1. Well, I don't need to take 3 inputs. Do I need 2 inputs? How? I'm not entirely sure how this works, so let's have a play around. So we look at memory slot 0. That so there's an input. Input select. What input number should be routed to the output? Oh, okay. Okay. Oh, well, that's simple enough. So if I do something like this, we have a... let's get rid of that. There's an input, and there's another input, and then the memory value. What's it going to output, though, if we feed in something? Let's try something out here. Let's give it a number which doesn't exist in our input. I assume it's going to give us a... Yes, excellent. That should work. That should work. So here we go. We need our wonderful counter system like we had before. And let's change that to a... In fact, I can bin that off and I can use this. That goes around there. And then that is feeding into the memory slot. And that should go into that. And then we need a writer, and that output, that's going to be written in there. No, actually, I've messed this up already, but it's an easy fix. Let's swap that, and let's swap that. That needs to go into there, and that needs to go into there. And then memory slot, that's going to be that. And boom, think we're done. I've messed something up somewhere. Oh God, of course, yeah. I'm an idiot. Because we don't need that. We need that. Nope, still ain't working. Okay, let's reset. Oh, yeah, no, I am an idiot. Because that should be that. Right, this time. Third time's the charm, right? Boom. No, messed up already. Input 1, output 0. Go forward 1 tick. So slot 0. Yeah, okay. No, that's right. That should go into there. Because if we've got 1, we want to output 0. And if we've got 0, we want to output 1. And if we've got neither 1 nor 0, we're not going to overwrite anything. That should work. Why isn't that? That bit worked. Right, so now we're looking at memory slot 1. We've got 0. And so that should feed out 1. Memory slot 1 should be overwritten with 1. Is that... Oh, no! No. 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 I think that's all we need. We just need that, right? Because we're only overwriting... No. No. Nope. There should be no 1s. You're right. You're absolutely right. There should be no 1s. Yes. Yes. Yeah, okay, cool. I know how to do it. I know how to do it. Actually, there's 2 ways of doing it. There's this way. Wait, if what is it? Replace ones with zeros. So make that a 0. Right, that should work. It feels hacky. Feels like there's a better way. Whatever. Goal was 7, did it. Okay. The advancement of mankind, hey. Okay, let's go back to our puzzle selection. Ooh, a multiplexer, hey. That's an actual thing. That is an actual thing that is worth knowing about. Sorry, I'm just checking my messages here. People are sending me weird nonsense, very, very weird nonsense right now. Cool. Right, how long have I been streaming for? Because it feels like I've been doing this for ages. 39 minutes. Tell you what, let's keep on going for another 20 minutes and then I'll call it a day. Hopefully this has been fun and interesting. But yes. Right, let's go back. Okay, let's have a crack at the multiplex. Ooh. Writer modules cannot be placed or deleted in this puzzle. Right. Are you liking the input selector? I was going to introduce it to you, give you some useful tips. It's rightly called a multiplexer. Did you know that? I did know that. I did know that was called a multiplexer. Yes, I know I can right-click selectors to configure them. Store 0451 in memory slots 0 to 3. Okay. Right, so here's my input selector. Oh, that's easy enough. I'll just paste that. Yes, I can. Boom. Paste. Paste. Let's change these numbers. So what did it say? 0451. Oops, don't mean to move that. 0451. And I feel, you know what? I realised, yeah, I made a template for those counters, so I can just use that. But to reduce my input count, to reduce my component count, I can do that. Okay. Job's a good un, although the goal is 7 modules and I used 8. How can I reduce that? Don't like that. Oh, how can I reduce that? I don't know. Maybe I should just live with the fact that I've got 1 extra module. I need the latch and I need the adder. and I need the input selector, it all boils down to these numbers. I don't know. There's probably a way. I don't think I really need to worry about it. Zero, 4, 5, 1. Yeah, I don't know. Is the short answer. I mean, it works, so. Let's go back to the old puzzle select. Right, I'm leaving multiply for a while. Ones, hey? Looks like you're done with the input selector. Great, here's an output selector. Replace all zeros in memory with ones. Did I not already do that? I'm pretty sure I already did that. Okay, how does this output selector work? Passes its input only to one of its two outputs. What? What output number should the input be routed to? The value to be routed to one of the outputs. Oh, okay, right. I'm with you now. Yes. Oh, is this going to work? Need a reader. Also need the old adder. We don't need the writer just yet. Oi! Right, zeros become ones, right? Try something out here. Just for the sake of no. Copy. Paste. No. Copy. Paste. Good. I'm a little bit confused as to why I'd use this selector rather than the other one. Right, okay, well that's going to read it in. So if it's a 0, we want it to become a 1. And if it's anything other than a 0, we want it to be nothing, right? How can I configure this? Oh, I end up with multiple outputs here. So presumably I can do that, right? Because that's... Yes. Okay, cool. We're back on. We're back on. Right. So, If it's 0, it's going to output 1, and if it's not 0, it's going to overwrite it with nothing. So there we go, boom, 0. Write that at that address, and replaces those, does not replace those, replaces that one, we're done. Hurrah! Hurrah. Cool. I mean, are you winning, sir? I think I'm winning. I think so. Rock and roll. Right. Let's go back to let's try this alternator. Haven't tried the alternator yet. See what nonsense it is. You met Jack yet? Nice guy, right? So polite, so charming. I despise him. He wandered in just now and told me to work on this machine that starts at slot 0, sets even memory slots to 1 and odds to 0. Okay. Okay. Well, that should be simple enough, right? No, that's not going to work. That ain't going to work. However, we do want to start off here. What other modules have I got? I've got a latch. Okay, this is slightly more challenging because I have fewer options. However, I'm going to try something. I wonder if this will allow me to place those. Yeah, okay. I still can't place the things that I need. Right. It's the going back to 0 after going up to 1. So we're going to have to store something in a latch. That's going to be stored in that. I can't have multiple inputs to that, can I? No. That will store 1. Okay, let's try this. Cool. Except. Oh God, am I going to need another module here? This is a really ham-fisted way of doing things. This will work, but. Wait, even to 1 and odds to 0. No, I don't need that. Wait, no, because 0 is even. I do need that. I'm not proud of this. Especially because it doesn't work. What an idiot. I mean, it kind of works, in a sense. It should so. Right, I know why. I wonder. Wait, I'll mess this up horrendously, yes. Get rid of that. Wait. Naught minus 1, naught minus 1, naught minus 1. Shit, still starts it. I mean, fiddle-dee-dee. No, that's right. Yeah, because I can. Yeah, idiot. Right. So we'll have another adder. We're going to add that. And then that. I mean, yeah, this is still a horribly inefficient solution, but it works. Yeah, I can get rid of 3 of those modules somehow. I'm not gonna let this one slide. Okay. Because that's horrible. No, that's a bad idea. That might be better. I mean, that's instantly gonna... Cool. Well, that... I mean, it's still not great. I can still... Apparently, I should still be looking at losing 2 more modules. I'm not entirely sure how to do it. Losing 2 more modules. Fewer latches, maybe? I don't know. Not sure. Can I do it with 6 modules? Don't know. Okay, well, I mean, it doesn't matter. We've done that now. I'm gonna do the set memory because it looks easy. I told Fred we're doing this codename Silicon Zeros. Whatever Jack says, we're going to build Laszlo's dream, a computer that fits in an office, not a warehouse. You're damn right. Good idea there. My Amazon parcel is 7 stops away. Well, rock and roll. What can I say? I hope it's something good. Hope it's something worth waiting for. What we want you to work on is a CPU, a machine that runs programs, lists of instructions. Decode and execute the memory set instruction. Okay, so mset is obviously an instruction here. New RAM, excellent. What kind of RAM is it? How much you getting? Right, okay, so I'm gonna need a decoder. I'm gonna need to go through each of those as well. And I should probably have a counter of some description. Although don't need the writer to be there. Here's our counter. Okay. Need a reader as well. Boom. Okay, there's our instruction. Cool, so store the source value into the destination memory slot. Well, that's easy enough. Destination is in there, source goes in there. That's it, we're done. Cha-ching! What in Sam Hill is this? Yeah. How many resources have you put into this? How much time have you put into this? I mean, less than a minute by the looks of things. We're sure as heck not making our deadlines now. We all better start looking for new jobs now, unless you think you can fix this mess. Yeah, whatever, Jack. As if I take my orders from some guy in a suit like you. You know what I mean? 32 gigabytes of RAM. That's not half bad. Is it DDR3? Do you know what the CAS time is, or the RTC? Do you know any of the speed stats? What frequency does it run at? DDR4, not bad. What's the CAS delay? The CAS latency, as they say. Back to the puzzle. Corsair Vengeance. I can vouch for the quality of Corsair Vengeance, having 32 gigabytes of it in my own. Or have I got Dominator? I think I might have Dominator. I can't remember. 32,000 watt. What? No, that's not your CAS delay. Quick check says Corsair Vengeance DDR4 CAS should be 16, which is not bad. CAS latency 16, so that's 16 clock cycles per per access. Yes, I can confirm my RAM is not Vengeance, it is actually Dominator. My cast delay seems a lot quicker though. It's like 10. But it's not DDR4, so you know it's not about raw speed. Sometimes it's about bandwidth. Here's my DDR. Is my DDR3? Who knows? Yeah, no, mine is Vengeance DDR3, I believe, because it has 9 cycles latency. I think. Either way, that's some good RAM. That's some good RAM, baby. Plenty good RAM. Yes, good. Right, should we go back to this puzzle? Let's go back to this puzzle. This is quite cool. I mean, we're getting to the point where we're actually building our own computers here, which is pretty radical, folks. I'm still a little bit bummed out that I need to get 6 modules for the alternator, and I've only got 8. That's annoying me. Probably more than it should do. Multiply. Now, complexity nightmare. Whatever. Let's give it a go. You guys can see my inadequacy laid bare. Right. They want a machine that for every 3 slots sets the third to the product of the first and second. Now this is interesting because with my A-level students just today, I was teaching them how to implement a multiply program using the Little Man Computer command set. Now, I imagine this is going to be fairly similar, although we're more limited in what we can do here. So I've got an... Is that going to be any use to me? Not sure. I am not sure. So we need to do 7 times 2, and then we need to do 7 times 9, and then we need to do 3 times 4, and then so on and so forth. Okay, let's have a think about this. We're going to need some latches to store this stuff. I'm going to use latches kind of like registers, I guess. Oh, but how do we route the output? This is actually pretty difficult. Okay, right. Well, we need some sort of counter to tick up. And we're probably going to need to read the memory as well. Okay. Okay. Ooh, this is gonna be trickier than I thought. Yeah. Because we need to be able to... Because the only arithmetic we've got is adding. So we're going to have to Loop through multiple times. God, this is a pain. This is a head-scratching pain. Okay. Let's do some proof of concept stuff here. I'm going to hard code these values just to see. So that's how we can pull out both of these values. And once we've pulled them out, we need to add that on. Oh God, how is this going to even work? How is this going to even work? Right. This is going to store our product, and that is going to go into there. And we can use an equals thing. What's it do? Output 1 if the inputs are equal or 0 otherwise. And that should be set to 0. And that is our input selector, and also that will go to our right. And again, I'm going to hard code this in. And here we go. Okay. Oh Christ, I don't have a subtract. Oh. Really? Well, that's a pain. I was going to subtract from that until it reaches 0, and now I can't do that. Okay, I have to take a slightly different approach then. God, this is getting complicated. Let's do a testings. Okay. I mean, right. Okay. Good. Well, that first bit works. The problem is, at that point, we need it to reset these numbers. Okay. Okay, right, let's move this to a, so it's more reasonable. I mean, that's hard-coded, we're going to change that. That is the product there. And that there. What's this? That's just a constant adding. It's always adding 1. Should be whatever that is plus 1. And that should be just whatever that is. That should be whatever that is plus 2. can maybe cut down on the number of modules used by doing this. No, did not mean to do that. Problem is that is now going to increase by 3 every time, which is probably not what we want, because we don't want that to keep on going up. Let's sever those links there and just replace it with a 0. The limited number of controls that we have. So I messed up somewhere. That shouldn't be 49. That's done 7 times 7. What? That's better. That point, we want that. Ooh, yeah. Okay, I've got something in principle, but how do I now make that? How do I now make that a repeating process? Is the question. Right, we get an adder. We get an adder, and we only add something on. Yes, this yep. We only add something on when that is 1, which means if I now get rid of that, this could work. This could work. This could work. Not saying it will work. I'm saying it could work. Except we don't want it to add 1 each time. We want it to add 3 each time. But that's all right. We can just feed that into another adder. Again, there's too many modules here, and I feel I could do it with fewer, but I just want to get it working to start off with. Oh no, because that ain't going to work either. Because it's always going to add 2. Although, let's just test this out here. Right, so what we need to do... Ah, got it. Right. Yeah, let's use this. Let's use this. Yes. Yes. Of course. Why didn't I think of that before? That's either going to be... it's going to be 0 or 3, isn't it? If it's 0, we want to output 0. If it's 1, we want to output 3. I think we got this, lads. Think we've got it. That writes 14. We're now... Is this going to work? No, no, this ain't right. Oh wait, what's 7 times 9? It's certainly not 169, is it? God damn it. What am I doing wrong? That's going to run on forever. Let's stop that. Or at least this bit's right. Okay, that bit's right. That is going to add 3 whenever it receives a signal here to say that we're writing there. And it works on the first pass, but the problem is... it doesn't reset the values by the looks of things. The value here... Let's do a quick test run. So that's done that, and then on the next run it writes that value, and it has now read that value. It should have also read that value, yes. But it needs to reset that value. I know what to do. Need another one of these input selectors. It's either going to use that, or it's going to use 0, and that is going to be, that's what's fed into here, and that feeds into there. Wait, no, is it? It's not going to work. That bit worked. That didn't work, although it did reset properly. Yeah, there's shenanigans going on. I think the input selectors are the key. Okay, let's see where it's messing up. Ah, that needs to also be reset. I mean, I need another input selector. I think I need another input selector in there. Yes. 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 I think yes. No, wait. 3 times 4 is not 8. 7 times 10 is not 60. What's going on here? We're going... What, we're going 1 less? 6 times 10 is 60. 2 times 4 is 8. 6 times 9 is 54. Something's happening with this number here, which wasn't happening there, because our 7 times 2 worked properly. Then we end up with 0. Oh! Yeah, let's not use 0, let's use -1. Right. Although, is that going to mess up the first time round? Oh, it might. Let's try it. Feels like a kludgy fix again. Okay, that one worked. That's certainly not right. 3 times 4 is 11. Oh, it's... Why is it 1 less than it should be now? Oh, because that one should still be 0. Okay, okay. This time, I think this should work now. Yes. 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 Oh, do you know what, though? I thought I was using a ridiculously large number of modules, but the goal is 18. I reckon we could trim this down a little bit. Let's have a look. That was... I mean, they weren't lying when they said it was nightmare difficulty, that one. You know? Let's see if I can trim that down any further. So, what we got here? Got a 0 and a 3 and a -1 there. And a +1 there. Oh, I've got 2 ones there. I can delete that and I can join that there. Boom. So we're already down to... Wait. I thought I had... Okay. Actually, I wonder if I can just change the order of this here. If I have that there, and instead of having oh, balls, what have I done? I've messed something up. Should actually work with the 0 that we had before. Oh, for God's sake. Let's test that. Well, that works, and I've got it down to 19 modules. Can I get down to the goal of 18? Let's see. Okay, maybe I suspect here. Can I? No, there. This music's funky, man. Do 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 do. Seeing how I can ditch another module, but I can't really see. Right, what are we actually adding on here? Wait, do we need to even add anything on there? That's just that variable +1 to select the mem slot. Okay, that's fine. And then that's just the same mem slot. And that is what? We're just adding one each time. That's actually unrelated, but I've managed to reduce the number of modules there. Yeah, I think I'm going to struggle to get it down one further. I'm not entirely sure how I can cut an extra module out of this. Although that memory slot are they not actually joined? Yeah, they are. Don't think I need that at all, do I? Because that's just always going to be that plus 2. Yeah, I don't know. Because I'd still need to have another adder with an extra +1 on it somewhere in order to get to that point anyway. Although, wait a minute. Memory slot 2. Nah, I messed that up anyway. That's wrong. That should be... that. Yeah. But again, don't really know how I can reduce my modules one further. Let's rename these. Oops. This is is it multiplicand? I don't know. I'll put address of num2, and here, nope, that's address. Is that the no, that's not the address, is it? Let's leave that. It's this one here. That. Wait a minute. No, I do need that. I do need that. Do need that. Yeah, don't know if I can make this any more efficient, at least not with my current brain thinks. Oh, I know what I can do. No, that wouldn't work. Oh, yes, it would work. It's. I think it's hacky as hell, but this might work. Although I am using that 0 for a lot of things. Where is that used? That's. Okay, this might not work. Where is it being used? It's being used there, there, and there, which means if I feed that into there, and where else was it? There, and that into there, and that into there, This might work. It seems to work. It's a hacky kludge. That is a very hacky kludge, but you know what? I think... Oh no, it doesn't work. It doesn't work either. It doesn't work. 3 times 4 is not 9. What are you talking about? Of course, because that still needs to be 0, doesn't it? That still needs to be 0. Okay, let's... Although... No. Because basically if that's 1, that needs to feed through. That's the problem there. I still need that. I don't have a constant 0 value. Do not have a constant 0 value anywhere. At least I don't think so. Oh, wait a minute. Yeah, that definitely works there. Yeah, I think we're pretty much done. There's probably one weird kludgy fix to get this working, but I don't know what it is, unless I could have a... No, that's just going to add extra bits. Yeah, this is the bit. This is the bit here that kind of messes things up. But it really needs to be that way, unless if that's 1, we need to store 0, but if it's not, that's... Yeah, do you know what? I'm gonna say we did it. It's not the most efficient it can be, but it's pretty damn close. The goal is 18, and we did it in 19. And that was a pretty tough puzzle. But job's a good one. Ish. Right, let's go back to the thing. So we've done the multiply. That was a nightmare complexity one. And that, my friends, is about all we've got time for right now. Maybe I'll come back to this. I mean, there's a couple where I didn't meet the goal. I met the goal in these ones here. Not quite that one, although I'm pretty pleased with actually having finished it. Didn't meet the goal on the Alternator as well. I can potentially store... I could potentially use 2 fewer modules on this one, but who knows? Maybe I'll come back to it with fresh eyes and everything. So there we go. That was Silicon Zeros. Hope this has been interesting and fun for you to watch. It's well worth grabbing a copy of the game. It's pretty damn fun. That's it. That's the end. So I am going to sign off and go and make myself a cup of coffee.